For our lesson for 326 Tech Tools, we decided to talk about conic sections, in specific the hyperbola. Now, the big things that we wanted our students to be able to do was to make a connection between the general definition of a hyperbola and the distance formula, which is necessary if they're going to derive the equation for a hyperbola. So that's as you can see, that's our next objective. We want to give them the definition and a graph, and we want them to be able to derive the standard form of that equation. And hopefully using their prior knowledge, they'll be able to verify this and gain some good knowledge out of it. It's very, very stressed in the Common Core standards, so it's something we really, really wanted to stress for our students. As far as technology was concerned in this lesson, we used the smartboard by having students come up and write their answers to this bell ringer activity that we have. This bell ringer had students using the distance formula just to get them warmed up on that. Some of them may not have done it in a while, so we were using that to get it fresher in their brains. And down here, this problem number 3 applied both the distance formula and the Pythagorean theorem. And as you'd see, the Pythagorean theorem comes in at the very, very end of the long proof of the equation for the hyperbola. So we wanted to kind of sneak this in there and give them a little bit of a heads up on it. I also created a GSP file that these students could use and look at and play around with. This file made it so that you could alter A and change the hyperbolas that way. You could alter B as well. And also you could do H and K. And then I also have these two buttons that would move H back to 0 and move K back to 0, and that would center the hyperbola at 0, 0 again. Now, these two buttons up here show the right measures, so it shows the measures off the right hyperbola, D1 and D2, which become necessary when we start proving things. And then this is off of the left parabola, and the measurements fall over on the left side of the screen. And all of these measurements may become more important as the students progress throughout the lesson. So, I'm going to be giving students this sheet. This sheet, it's pretty blank because we're asking a lot of these students. We want them to derive the equation of a hyperbola based on the definition and the distance formula, and we ask them to refer to that GSP file I just showed you for reference. So we give them the definition. It's a hyperbola is defined as the set of all points such that the difference between the distances from the focal points to the hyperbola is the constant, and we're denoting that constant by k. So we didn't want to just give the students this thing and say, here, go. We wanted to have them get some guidance and work together and get that student communication going, and we were able to see a lot of people bouncing off ideas off each other as to how to approach this problem. So something that we did, if I pull up my answer sheet, if I can find it, sorry, it's this one. We started out by kind of breaking this big long proof up into portions, and we had expectations that we would want our students to get to this point in 7 minutes, and we wanted them to place the work above here up on the board so that way everybody else in the classroom could see it and could, figure something out for themselves by seeing what someone else had done. You look up there and they do something a little different, and oh, something clicks, and now you're up and caught up and together with the rest of the group. So we break the rest of the proof up like this for the most part. Each place where we see, duration would be a good place to stop and have students write what they have up on the board. Even if it's not correct, it would be good to go out there and have them discuss why they think it's not correct, how they think it could be improved, and things like that. So we get down here to the last duration, and we have c squared minus a squared, and that is where the Pythagorean theorem comes in, right here, making this little substitution, and that's where why we had the Pythagorean theorem in our warm-up. We also had exit slips for these students to work through. The exit slip was applying the definition. I was given 2 foci and 2 points below. I wanted them to verify that these points form a hyperbola. So if I pull up the answer document, I can show you what I expected for their answers. So what I expected them to do was pick a D1. In this case, D1 is the distance between this point and this foci, or this foci, and work that all out. And then D2 is from the same point to the other foci. And then we take D1 minus D2 and we get some constant, 8. And then we do the same thing down on this side. Take a point, pick a foci, find the distance. Take the same point, you pick the opposite foci, find the distance, and they both worked out to be 8. So we say down here at the bottom, said because the difference between the distances between each point to each foci is the same constant 8, these 2 points will lie on the same hyperbola, and that's basically what we were going for in our exit slips. So that's about all we worked through for this lesson. If you guys are wanting any of these materials or anything like that, there'll be an email attached at the bottom of this file that you guys can contact us with. We'd be very willing to share this with all of you. Thanks.